Just about myself, actually, I know there's a white page there, but basically I am a software engineer. I've been working in the IT industry almost about 21 years. I've been here in London over 20 years. By day, I am software developer. By night, I will convert myself into an author and writer, a speaker, mentor, all kind of things towards the second part of the day. I am currently working on a book, Elasticsearch in Action, second edition, which is basically taking all my time up to 2 o'clock in the mornings. Um, I have written a couple of books on Java and Spring technologies. So, and also train on the Elasticsearch with Aurelie on online live trainings. So, do please join me if you can. Now let's not waste time, actually, because as I said, we only have 20 minutes. So let me go with the introduction of the subject. I'm pretty sure you may have hailed a cab. I know we are in the difficult situations. Probably we might not have gone onto Uber for almost a year or so, but you may have hailed a cab recently, or searched a GitHub code snippet on the GitHub. Or you may have received an email from Netflix saying that, did you watch the new movie, something like that. Or you may have, because we are on the difficult times, may have used the Tinder in one way or the other way, searching or swiping left or right. All these things, they are all powered by Elasticsearch. And just not this one, there are humongous applications used and use cases used across the ecosystem of Elasticsearch. Now, just wanted to get you this context, actually, where we are with the search. Search is actually become a new normal. It's become one of the most integrated software functionality into any application, enterprise or core applications across the web, across the app applications, any part of the IT systems. So don't get mistaken with that naive-looking search bar. There is so much of algorithms, so many data structures, so much of computing power is spent across, or is been derived behind that, or been hiding behind that little search bar. Of course, businesses nowadays, actually, they become more or less, search has become their survival as well. So it's like most of the searches, most of the sites, or most of the applications where you have search, probably they may lose the competitive advantage over the other competitors as well. And it's just not for end users. If in an organization, if I'm working in an organization, I would expose my data, because I'm collecting across the whole lot of data. We'll be sitting on tons and tons of petabytes of data, and that data can be distributed across the organizations for business analysts, or internal applications, or anyone at all. It's just not for end customers. And one of the biggest challenges, the full text search. That is what actually the search engine is all about. The modern search engines are really good at full text searches. So full text is nothing but the human language, the language which you speak, the relations between the words, and making sure that the relevancy is part of that particular one. I'm going to show you a couple of examples what I meant with relevancy with respect to BBC, and comparing with ft.com as well in a minute. In addition to these things, actually, analytics has become a part and parcel of search as well, because you're massively collecting all the data into your application for searching functionality. Remember, for search, you need to have the data already into your system. So you already ingested your data into your application or into your search engines, and then you're trying to do some searches, finding a needle in the haystack. But the other way around is analytics. So that is, you're trying to look the data upside down. You want to find out the aggregations. You want to find out how many sales were happened last week, or some sort of a little bit higher level than that. So that's where your analytics come into picture. And of course, machine learning, because you already have data, you can enable features of machine learning. And most modern, this is one of the biggest modern search engines capability as well. In fact, Elasticsearch is big on integrating the machine learning features into the application. Okay, this is my Millie. This is our small little pet we just got about a year back. And as you know, being a first-time dog owner, we frantically start searching for dog food. So I obviously, first thing what we do is that we just go onto the online search engines. So I went to one of the customers, one of the locals. I don't want to name, but one of the local supermarkets, or in fact the UK supermarket. And as you can see, I searched for dog food, which is on the top right. You can see the search bar, and you can see the first line. I got something called sponsored items, and this. Can you also see there is a unnecessarily or irrelevant, like poo bags. I am not interested in poo bags at this point of time. I'm interested in dog food, but unfortunately, search has kind of let me down there. And I went into another one, for then I started looking into a little bit detail actually to see actually how exactly other engines also start looking at. So I'm not interested in harness, right? So unfortunately, this also kind of failed. Um, this again, sausage dog has nothing to do with what I'm looking for. There is one particular one. I mean, in fact, actually, I didn't put all the messages here. There are multiple sites which have really given the right indication, but this particular one I want to show you here. It has really gave you a lot of information here, including sponsored items, as you can see, including the top. On the top, you can see there are drill downs, so you can sort out. You can sort the data that these are all like picking up in a particular category. Picking up the size of the whatever the one, including, I think there was some other sites which are given the prices as well, a range of the prices. So it's kind of a drilling down or making sure that the customer has got much more user experience, much more happiest experience when you're doing the search. Search is predominantly for the customer to return back. I mean, it's going to be helping the customer to have a fun experience, at the same time very, very functionally rich experience. So that's exactly what it is going to be. So I don't think that any of them has like Elasticsearch behind the scenes. I just took it as an example. And obviously, I went on to our good old Amazon. The minute I start searching for dog food, as you can see, you could get all the suggestions to you straight away. And I tried, making a spell mistake. It did say that, did you mean dog food, which is really good. So, that's one of the things. And ultimately, I went on to Google as well to find out what exactly Google is trying to do. But of course, it's not for dog food, but it's something else. As you can see, it's already started giving me the data, what I'm looking for. So it's more of the search is actually trying to give you what you are expected to give in a relevancy as being the topmost priority. Now let's come back to the Elasticsearch. Elasticsearch is a open source, distributed, and highly available a search engine. It's nothing more than a search and analytics engine. Of course, you can also use it as a data store, but I wouldn't suggest you use as a primary data store. You could use it as a secondary data store. So it's kind of it's a pretty fast. When I say fast in the sense like the second you index a document, you are expected to be able to see that document just about, I think, in a few milliseconds. In under a second is the SLA given by Elasticsearch. So all in all, it's a search engine, and on top of search, you also have analytics. You also have storage on that as well. So one of the important things about the analytics search engine, sorry, Elasticsearch, is that is built on an open source product called Apache Lucene. Lucene was there since 1999, late 90s. Dark Cutting has produced this particular really amazing product, but that's a it's a Java-based library. So what Shea Bannon, the founder of Elasticsearch, has done is that he has taken the product, he has built around the product all the bells and whistles which are required for the distributed technologies, which are required for the scalability of the product. Everything has been taken care actually from that perspective. Now, I'll just give you very briefly the functional and technical features of Elasticsearch. In fact, actually, these are mostly sometimes are relevant for most of the modern search engines, as well. But in the first few of them, I think more relevant to Elasticsearch than other ones. Obviously, full text, as I said, is a human readable languages. You, like, for example, think of as an email text, or some sort of a vaccination text, or a data on the NHS website. You wanted to search through that data, so that's one thing you are going to ingest into the database or into your Elasticsearch, and you wanted to find out relations or find out that particular data across all the data. Basically, somebody having to go through that search, you are expected to provide that data back to the user. Relevance, I'm going to show that in a second, but basically all relevance is to say that, okay, if I'm searching for a particular term, I'm expected to get the similar kind of results, not necessarily exact results, but mostly relevant results. So you would be, like, if you go into Google, if you are searching for some vaccinations, for example, you are expected to get something around the vaccinations, vaccination centers, all those things for in the COVID world. Or even if you search for inoculations, more or less it can be kind of changed into the word jabs, or all of these are going to be changed into vaccinations, because more of a synonyms kind of thing. So the relevance is more about, and you can also see relevance is about, scoring is giving a score to your search results. So the highest relevant document is going to be given on the topmost of your search result, whereas the lower relevant results are going to be pushed down to the list. And obviously you must have seen all these auto completion and suggestions in your daily life. Is basically, providing you some sort of mechanism to say, okay, this is what it is. Are you really asking for, if I'm searching for at a coffee shop, if I'm a cafe, if I'm searching for Wi-Fi instead of Wi-Fi, if I'm searching for wife, maybe it will suggest me saying that, are you searching for Wi-Fi, nearest Wi-Fi, something around that one. And fuzzy searches are all about, if you're making a mistake, how would a system can analyze that one to say, did you mean so and so? Just like the way I've shown you earlier, instead of dog food, I put dig food, which might have analyzed by the system to say, did you mean so and so? That kind of thing. And more of a highlighting is all about how you want to show that to the end user to say, these are the bits that highlighted in your particular search results. So this is a huge document, but these are the words you have show your search results are around this one. So I'm highlighting that to the, and analytics and machine learning is another functional feature, pretty much very good. On the right hand side, you can see the technical features, which I don't need to explain again. They are more of a distributed nature and scalability and fault tolerant. Obviously, Elasticsearch is much more resilient to failure. The best thing I like is the multi-language support, and also the rich set of APIs. So what these are basically, you don't need to have an application running only in Java, because Elasticsearch has been built, or is built in Java language, but doesn't mean that you have to use the just the Java language. You can have a Java client talking to the Elasticsearch. You could have Python, you could have Ruby, you could have any of the clients if you want the language clients, but you can also have a language agnostic client. So for example, REST-based applications, any of the REST-based applications, including Postman, including advanced Java REST, any of those REST-based applications as well, because Elasticsearch exposes all its APIs via the JSON-based REST APIs. And there is a huge capability for you to start looking into providing the visualizations of the data. So you have amassed a lot of data, you want to show some visualizations, you can use the Kibana tool to do that one, which I'm going to show you an example in few minutes. So again, this is a thing of a beauty. Really, the good thing about this one is that you more or less, you bring it out, you install on your machine, it should start working straight away on your laptop, on your PC. It's kind of, complexity is really beautifully wrapped away, and it's mostly, it works everything by default. It's got all those things, software paradigm of conventional configuration. It has embraced that particular paradigm. It's got consistently, it's got really beautiful rich APIs, which you can talk over the REST API or using the native clients. And I'm going to explain to you in a second what exactly modular architecture are, but basically that's related to the Elastic Stack, which I'm going to show you in a second. Again, there is a huge adoption of Elasticsearch in the industry across plenty of applications, or plenty of companies are using this particular technology in and out. So there is no reason why you shouldn't be using that at all. Now, just I wanted to show you. So basically, that is a very brief high-level introduction. So I just wanted to go through you with a little bit of fundamental concepts before I can show some hands-on information or hands-on examples for you. So all in all, Elasticsearch is a distributed application. It's a server-side application. So when you start on your application, it's kind of like bringing up a node. Elasticsearch is nothing but a node, or a running instance of an Elasticsearch is your node. It is expected to have documents of JSON formatted documents to be indexed into it. Indexing is nothing but just like the way you put your documents into, you insert your documents, or sorry, you insert your records into database, you ingest or you index your documents, JSON-based documents, into Elasticsearch. So a similar kind of analogy between Elasticsearch and the relational database systems there. So Once you have a single node, it's up to you. You can always go on create distributed architectures, distributed clusters. So in this particular example, you have a single node cluster on the left hand side, where you can have one node doing all the jobs for you, or you can also expand that to having multi-node single cluster. So in this particular instance, ABC are three nodes working through together to make a single cluster. It could have a number of shards, which I'm going to explain to you in a second, and taking the load from the search as well as from the indexing perspective, all doing the three. If you really want to spread out, you can also do the multi-node, multi-cluster as well, so that all ABC nodes on the top one are going to be different from the ABC on the second cluster in this one. Each of the node, this is really important, each of the node has got a particular role, which basically more or less all the nodes are going to be coordinator roles. But in addition to that one, some of them can be can be named or can be put as data nodes, and some of them can be master nodes. Data nodes are the data intensive nodes, that is, they are the ones who are going to take care of making sure that the data is actually ingested or indexed into the Elasticsearch cluster or Elasticsearch data part. I think we already seen this one, so I'm just going back actually. Okay, so in a typical, this is a common architecture in a typical environment. So you have on the left hand side, as you can see on the green box, that's your search service. You are expected to have some sort of a search service or some sort of a component hiding away Elasticsearch. I wouldn't suggest, this is one of the best practices. I think I wouldn't suggest you to expose your Elasticsearch to end clients, but more or less you can have something called search service in between. This particular one is actually talking to the clients. Clients are sending the request to the search service, and search service is actually talking to the Elasticsearch to get the data, to ingest the data. All those things will happen behind the scenes. In addition to that one, as you can see, there are three other components. You can see Beats, Logstash, and Kibana, which I'm going to explain to you in the next picture. This leads to a larger picture of what Elastic Stack is. So basically, if you look at the picture very closely, there is a heart in that, which is the Elasticsearch. That is the heart and soul of the whole Elastic Stack. Now, if you ask me, it's just not Elasticsearch. Elasticsearch itself might not be relevant for you. In fact, actually, you can just take Elasticsearch and just go and do your application. You don't need to have anything else. But I would suggest that you should also consider having something called Kibana on the right hand side, which is your visual interfaces. And or if you really want to have some data processors or data processing engines, maybe Logstash is the one. Logstash is basically a mechanism to churn your data and put it into Elasticsearch. For example, you have data shippers called FileBeats, Heartbeats, and all those beats. They're called beats actually. And those beats are deployed on the virtual machines. For example, you have a stack of virtual machines, you deploy them on that. And all those things are going to do is to extract the log files, extract the metrics or any sort of information. They can talk directly to Elasticsearch, or they can talk to the Logstash, and Logstash will be able to send that data into Elasticsearch by indexes into the Elasticsearch. You can also have your own search service. In this case, as you can see, there is a service which is sitting in front of Elasticsearch, which does the indexing as well. So it's kind of it works both ways. Obviously, internal applications can talk directly to Elasticsearch, or you can also expose your own search service to be talking to the external world as well. So if you want to take away your any slide home, this is the best slide I would say to think about that one. I did mention something about shards a few minutes back, but I'll explain a little bit, kind of show a little bit in application, and maybe you can take it from there. So let me show you something here. I hope you can see my screen. So what I'm going to do is that I'm just going to simply add something called, let's say, I'm just going to create a news index. I'm just going to post a document, right? I'm just going to create, this is my JSON document. So I'm just going to have name value pairs. In this case, let's say I have a title of a document. Let's say, I don't know what exactly BBC is today's. Let's say we are trying to do something COVID legacy, I don't know, but let's see actually. Okay, so we're going to create a document. So all you're doing is that you are creating a table called index. In this case, what we are doing is that we are creating an index called a news. In that, we are trying to post a title, or so post a document called title. So you can start adding this data. So it's equivalent to inserting a record in your database. So all you did was basically, if you take the analogous to database, is basically a news is your table, and in that table you are actually setting the document record with the title being a column being the COVID legacy being the value of that column title. Now, this has actually, what happened is that this created an index. So index is nothing but a logical collection of your data, of your documents, of whatever the information you want to put in place. In this particular instance, I have created something called news, and that news is actually is going to start hosting all your documents. So if I create something like Twitter, or if I create something books or students, they're all going to be part of that. They are all the indices which going to host that particular type of data you are trying to index into the application. So if I go back to my screen once again here, so that index, what I was showing you, that is your news index. For example, in this case, I have created an index called news on the fly. Of course, you don't need to create on the fly, but Elasticsearch is really forgiving. It can allow you to create indices just like on the way, just like on the fly. Unlike in a database, you have to create that schema upfront, but you don't need to worry about it here. But I'm not saying that you should go that route in production, but that's a different approach anyway. So in here, what we did was basically we created a news index, and this index is actually going to be in my system at the moment. I only have one node, but ideally you have multiple nodes running in your application, in your infrastructure, and each of that node is actually going to be each of that index is going to be supported by nodes. So in this case, I have shards. Sorry, in this case, I have shard 1, shard 2, and shard 3 being supported by index. So index is a logical collection happening behind the scenes. It is being supported by 3 shards. Shards are nothing but the Apache Lucene instances. So they are actually the ones who are the hard workers, who are the workers who are actually going to start taking the news items and start pushing them into the file system, because actually Elasticsearch, the store is all about document store, is all about making sure the map FS is the store for Elasticsearch. So in this case, if I'm putting a document here, one of them becomes a coordinator, and this coordinator is going to say, okay, this is a document. I am going to give it to I'm going to find out where exactly this particular document is going to sit. It's got something called a hashing routing algorithm to find out which shard I need to go. It's going to put it in one shard. The minute you have in one shard, for example, if this document ended up in shard 3, for example, the replica of the shard 3 is going to be on a different node. Replica is nothing but a copy of it. Should your node see false flat for whatever the reason, you still have the data on the replica. So that means actually this is going to be promoted to your shard 3 until this node comes back in action. So more or less what happens is that you are creating a fault tolerant system by making sure that these particular replicas and shards are distributed across your nodes. Plus, in addition to that one, the shards are actually going to receive the data ingesting requests or data indexing requests, whereas replicas can be useful for you to have much more read capacity. So what it means is that you don't need to have only one replica per shard. Instead, you could have 10 replicas per shard, as long as you have the capacity, disk capacity on that node. What it means is that if your system is actually highly read intensive, you could have multiple replicas, which will make sure that the read requests are being taken care by those replicas. So it's kind of a win-win situation in that case. So it works very, very, very well. Now, this is the mechanism how indexing and search works. So as you can see on the top, there is a document which is going through an analysis phase into the node, which is a coordinating node, and the node is actually going to take the document and index it, and indexes it obviously into its index, which is supported by these 3 shards. Now, this is a big picture which is going to be in a couple of slides I'm going to show you, but analysis is the main thing what a modern search engine is actually going to build upon its search capabilities. So any data which is coming in through needs to be churned through so that it is easily searchable and it is easily representable by your search queries which you are going to do that. For example, in this case, I'm just I'm sending a query that also goes through analysis phase. Of course, there are different types of data. For example, Some of the data you don't need to do the analysis. So for example, credit card details or social security numbers, you don't need to do analysis. You can just simply send it as non-analyzed fields. Those are called keywords. But some of them are, like for example, a research article information or blog post that can be, or a movie synopsis, that is part of your analysis. It has to go through analysis because you are going to look at that particular document in a minute, whenever you're trying to search that document. So in this particular instance, I got 3 codes. For each of the code, for example, an index is going to be created. Something called an inverted index is going to be created, which I'm going to explain to you here. So look at this one. On the right hand side, you have this quote which is coming in through. So in the analysis phase, this particular data is actually going to be really massaged into the way Elasticsearch wants, in fact, actually Lucene wants. So you have something called character filters, tokenizations, and the token filters. These are the 3 bits which work together to make an analyzer. So, if you are sending an XML, for example, or HTML data, that character filter is the one which is going to be split that, or scrap the, take that XML tags and clean that data, and then gives it to the tokenization. Tokenization is a process of converting into tokens. The data is going to be tokenized. So for example, in this case, the imagination is going to be one token, is going to be another one. So that is white space is the one which is going to be used to tokenize your documents in this particular analyzer. And ultimately, if there is a like capitalized imagination, that is going to be kind of lowercase to lower in imagination. So something, these token filters are going to churn the data, which might be applying some stop words, or applying lower casing, and there are different token filters we can use. And ultimately, the the heart and soul of Elasticsearch is going to be this guy. So it's basically inverted index is if you think of inverted index is like a book index behind the when you see at the end of the book, where you see a word and where you find where exactly the pages are. Exactly like that, when I'm searching for an imagination. So before I go to the search site, let me explain what happens to the how exactly the inverted index is going to be created for a particular field. So this goes through the process of analysis, and you in the analysis, during the analysis, a word is going to be created into that index, and obviously the first document is going to be tagged to that particular word. And when a second course comes along, in this particular instance, if imagination is part of the second code, then you're going to keep adding the document number to that imagination word. So keep on for that particular field called code, you're going to create an inverted index, and that inverted index is going to start building up the words. And when I do a search on imagination, for example, you are actually going to, or Elasticsearch is actually going to consult this data structure called inverted index, and finds out, okay, imagination has got these 2 document numbers 1 and 2. Now I'm going to find out which shard these document numbers are there. Is going to use that sharding algorithm, routing algorithm, which I mentioned it in the earlier slide. Goes to the slide, goes to the shard, brings those 2 documents, and serves to the client. So that's the way it's going to all work together. So it's a little bit more than that, but keep this in mind, that this is the performant data structure we always use for search and analysis purposes. Again, I don't want to go into details, but this is the overall picture. So you can have multitude. I think there are custom analyzers as well, but you have a standard analyzer, you have an English analyzer, you have simple white space, and there are quite a lot of inbuilt analyzers. And you can also build your own analyzer. Like for example, if I'm working with Arabic language, or if I'm working with Chinese, or any of them, you can also build your own. Or if I'm working with like language from Mars, I may want to analyze that particular data coming from the Mars. Maybe I can create my own analyzer as well. It's up to me. So again, I don't need to go like too detail in there, but we already discussed on this one. So just coming back to this one, there is Elasticsearch has got something called search a lot number of bells and whistles. So the term and full text queries are the topmost search queries. So term queries are nothing but it's like a Boolean queries. You ask for something, you're going to get exactly whether yes or no kind of value. It's more of a database kind of search. When you go to database, you ask for something to say, give me values of flights from this particular date to that particular date. You're going to get X number of data back to you. Same thing with the term as well. So you are actually going to say, you're going to get the results based on your Boolean kind of answers, yes or no, whether you match or not, don't match. Full text on the other side are more of a relevant. How it's not necessarily whether the document has matched with your query, but it's more of saying to you that whether how well this particular document is matching with your queries. Kind of how well is very, very important. That is what it kind of distinguishes a search engine, that's modern search engine, with the databases, that how well the document is matched. Obviously, you have plenty of query searching facilities in here. You can go for geo queries. You can do the fuzzy, as I mentioned, prefix and phrase. I don't need to go all of them. I'm just going to give you a GitHub later on, a GitHub URL. You can go and do your experiment with the code as well. Coming back to the relevancy, I just want to show you one quick one. So let me go to BBC website, because I think we are on the BBC. So I just opened it beforehand. So there is a small search bar there. So I just wanted to search something. Let me search rocket threat, right? Because that's a thing going on here at the moment. So let me, if I start searching, I can't really get all the if you see, this is not being indexed at the moment. I mean, it's not being appearing in my suggestions at this point of time. Maybe not necessarily is indexed in that way, but rocket threat. So I just kind of searched, and if I search this particular one, I do get that one actually. So that's basically, so this particular document is BBC, the search engine behind the BBC is thinking that whatever I searched is actually, this is the closest match, and this is the more relevant than probably towards the end of it, when you have 11 pages of that. Maybe this is not necessarily the closest match. So if you look at this particular one, I mean, obviously every search engine will have its own mechanism to create what you call relevancy algorithms. But in this particular instance, if you look at it, right, the rocket threat is actually inside in the title itself. So probably there might be an algorithm behind it to say, yeah, this is because your title has matched with my title, so I'm going to give you more weightage to this particular document. So you're going to get that back to you as a result. So that's something which is giving it to you. Let me go very, very quickly to Financial Times as well. Let's say let's pick up one of the quell violence. So I just searched something. EIOLDNC. So if I do search, by the way, in the BBC, you're not getting any highlighting, right? Remember that. Whereas in the FT, you can get the highlights. So they are actually giving you the highlights here. So if you see, this is also kind of relevant. If you go to the end of it, most likely your relevancy has started decreasing, because that quell, that is actually, this is the highest one, because that particular value is actually in the in the title itself. So I think more or less it's kind of similar kind of algorithms they must be using. I don't know whether FT and BBC are, I don't think that they're using Elasticsearch, or maybe I could be wrong as well. But that is, the relevance is all about how closely your search queries relate to the one which you're looking for. In this particular instance, keep in mind, the search engine has to do much more work. It not necessarily, and by the way, you can see that it's also sorted by relevance as well, as you can see. It not necessarily, it has to just search against the title, but it also has to search against the body of the text as well, and probably there might be some metadata as well. It may have to search across that information as well, and based on that one, it's going to provide the search result a particular score, to say, okay, this particular document has got 1.5, whereas this has got 1.4 scorecard. So I'm going to put this in the second spot, and this is going to be first spot. That is the relevancy is going to work. So let's go back to our slides again. So it's a scorecard. Relevance is more of a scorecard. It's kind of a number indicating how closely the document is actually going to match with your query. And in Elasticsearch, this is, Elasticsearch uses something called best match 25, or copy best match 25 algorithm. The simplistically put, there is, if you think about the algorithm, I'll just give you a very, very brief explanation. It uses something called term frequency terms against inverse document frequency. So term frequency is nothing but the same thing what we just looked at earlier. If a word happens to occur more than once or X number of times in the same field, then that might be more relevant than in different fields. So I'm looking for a title field, and if that let's say in that earlier example, if that title field has got more number of times the same, like same word, that means it is more higher. So basically, it's the term frequency is the frequency of the search word in that title actually of that particular document, or in that particular field of the document. And higher the frequency, obviously the weight is going to be much more higher. Whereas the document inverse document frequency, the document frequency is all about, you're actually going to you're going to look at the across the all the documents, across all the index. So it's kind of, you have a bigger basket here, you want to compare against that one, how frequently that particular word is matching up with other documents in that index. So the more frequently, that means, for example, take a word is, or the, or and. Now those kind of words are more frequent, right? So you might have to reduce weight on them. So it's kind of, that's the reason why you call inverse document frequency. So, this is something which you don't need to worry at all. It kind of, internally Elasticsearch does that for you. Now, I just want to show you a couple of search types. Actually, let me show you search types and then we can go. There are two types of search. You can use a URL search. You can use the query DSL. I think URL is more of, you can use something. You can just finally attach something to the end of the URL, which you can create as big as possible, but I think it's more error prone. It's less looked upon, so I wouldn't suggest you to go unless you really want to experiment some of the features of Elasticsearch or some of your features of your search engine. The second part is basically using the query DSL. Query DSL is all about using a simple as you can see, this is a simple URL, right? You have an endpoint, which is search endpoint, and passing a JSON object here. So in this case, I'm just passing a JSON object with a query saying that, can you match this particular index people with names being John? So I missed the double quote there. So that is the that is the query DSL I'm just going to match in this particular instance. So it's kind of, we normally work on the query DSLs, which is actually really, really good for us. Let me show you this one actually. So in this particular instance, I have a term queries which says, I mean, there are two types of queries. You have a term query, you have a full text query. Term queries, as I said, they're going to be giving you exactly what you want. In this case, I'm just going to search for Joshua Block, the author. You're going to use a term query. Or if you can also use the range query, where I'm going to say that from this books index, get me all the books whose Amazon rating is greater than 4.5 and less than 5. That means over 4.5. That's what I'm looking for, and so on. You can always pick up many of them from that perspective. On the full text queries, you can have a lot number of match queries and phrase queries, which I can show you here. For example, I'm just going to get you a query which says, this one match query. If I'm going to search from books, which says match any book with a tag being Java programming. If I execute this particular search, I will get something which says, this is a particular book which the tags is being programming languages. In this case, there's a Java programming language, so it matched with that one. Can you also see that I also added something called highlights here? That means I will have an additional additional thing to say that this is where your actual search query has been highlighted. So it's an emphasis on that particular one. Let me show you one more example, which is basically the fuzzy search, which basically I have a spelling mistake here. I searched for this one. Unfortunately, it had come back to me. The reason is that I have a fuzziness being 1. So that means the Elasticsearch is intelligent enough. It uses something called Levenstein edit distance being 1. It tells that, okay, this is the one character mistake, so I'm going to replace this one character with the other characters and see if it matches with my stash of documents. In this case, it had matched. You can always go with that one. Now, in this particular instance, I'm just going to have something called a phrase actually. So I'm looking for one long phrase, like, and lambda expression. So do I get that one? So you can use a match phrase query for that one. So in this particular instance, yes, there is something called in the synopsis I'm looking for, because that is the, that is what you're using it. And that's where you're actually going to get something from that. Of course, you can also, if, for example, if I drop this one, this will not, this is not a phrase, because there is a word which has been missed in that one. So I won't get any data. So in that case, we use something called slop. Now, slop is the one which is going to help you to say that, okay, so here I'm just going to drop that one, but can you add something called slop? So, slop one being that one word is missed, can you find out more information? So on. So, I mean, there are lots of search queries. So all I can tell you is that there is, I think, there is a GitHub page for you guys. You can, there is a lot of stuff in here. I would strongly suggest you to go and experiment it out. And it's not that difficult to get on board. One last slide I want to show you is that visualizations on the Elasticsearch are pretty good. You can have you can create your own visualizations based on your data the way you want it. In this particular instance, for example, I'm showing this. It's a sample data anyway. I can go through sales by category, or I can, and in this particular instance, but for example, I can zoom in and I can get what are the sales, for example, for that particular country. And then you have top selling products, like terms, actual terms kind of analysis on that one. So, is your, you can start exploring the data as much as possible. I think I'm going to pause there. I just want to give you a very heads up. As I said, Elasticsearch is a really huge topic, so I'm trying to condense as much as possible. So you can experiment that one, go into the GitHub and then do that one. So back to you. I get, thanks for that.